Okay, so in this video, we're going to be talking about solving trig equations, and these are going to be a bit more challenging. Now, I do have a video on solving simple trig equations. Make sure you check out that video before trying this one. I'll go ahead and link it below. But assuming you know how to solve these, let's go ahead and try some more challenging ones. And the key takeaway here is that you always want to isolate the trig function. Also, make sure you never divide out a trig function because you could possibly lose a solution if you do that. So for example, just kind of dovetailing off what I just said, if you have tangent theta times secant theta, and you have this equal to tangent theta, if you're trying to solve that, you may be thinking, well, I'll just go ahead and divide out tangent theta. That will make it way easier, right? So if you divide out tangent theta, both here and here, right? Well, tangent theta will cancel and you get secant theta is equal to 1. And so when you do this, you're actually going to end up losing a solution though, because if you go back to the original equation, that original equation has two solutions and it's going to be 0 and pi, okay? If you divide out tangent though, you will lose one of these two solutions, okay? So you never want to divide out a trig function. You can factor, that's fine, but do not divide out a trig function because again, you could be losing a solution. So that being said, let's talk about how we're going to solve this first one. So let's go ahead and get rid of all this here. And we talked about how our first step should always be isolating the trig function. Now, if you look at this one here, how do I isolate it? Because I have cosecant theta here, and then I have cosecant squared theta here, and then same thing, cosecant squared theta here. This one here, you can't isolate. It's not going to work, okay? What you could try to do, though, is factor, because I see that I have something that looks almost like a quadratic, and let me explain. If we say that cosecant theta is equal to x, okay, it's going to make this problem way more visual. And so we can do something here called substitution, where I'm simply going to take out one of these terms and substitute it with a variable for the time being. And then I'll resubstitute back in at the end. So for example, if I replace everything with x, wherever I see cosecant theta, I'll get negative x, right, plus 3x squared, and then equal to 2x squared, all right? So now you can see that I'm definitely dealing with a quadratic. And how do we solve quadratics? Well, we set them equal to 0, we factor and solve. So that's what I'm going to do here. I'm going to take this positive 2x squared and I'm going to move it over to the left-hand side. When you do that, you get x squared minus x equal to 0. And again, I just went ahead and changed the order here. That way x squared is coming first. All right, it's a little more neat. What do we do from here? Can you factor that? Well, I can pull out an x. They have a greatest common factor, right? So if I pull out an x, I get x, and then I get x minus 1, all equal to 0. And so from here, this is where you're going to substitute back in. What is x? X is cosecant theta. So you can write here cosecant theta times cosecant theta minus 1 is equal to 0. And so when I solve both of those, again, I have to take each one of these factors, this factor here and this factor here, set it equal to 0 and solve, you get cosecant theta equal to 0. And then you get cosecant theta is equal to positive 1. Again, adding that 1 over. Now, if you saw my last video on solving simple trig equations, you know that I do not like leaving things in terms of the reciprocal trig functions. So for example, we know that the reciprocal of cosecant is going to be sine. I want to be dealing with sine, cosine, or tangent at all times. I don't want to be dealing with these reciprocal trig functions. So to get around this, we're simply going to flip everything, and then I'll have it in terms of sine, right? Because we're going to take the reciprocal, meaning we're going to flip. So if you look at 0, well, 0 is really over 1. This is 0 over 1. If I look at this value right here, right? If I flip it, it becomes 1 over 0. So in other words, you can say here sine theta is equal to 1 over 0, okay? And if you do this one here, this value is really 1 over 1. If I flip it, well, it's still going to be 1 over 1. So when I flip it, I get sine theta is equal to 1. Now I have it in terms of sine right here, right? And it's going to be way easier to use your unit circle over here, okay? So that's what I'm going to do, okay? So what you have to say to yourself now is, when will sine theta be equal to 1 over 0? Or in other words, when will sine theta be undefined? And well, that doesn't exist, because on this unit circle going from 0 to 360 or 0 to 2 pi, because that's what they want us to do right here, right? Solve on that interval. Sine will always be defined, right? So this one right here doesn't even help us, right? But if I look at sine theta equal to 1, when will sine be equal to 1? Well, there's only one spot here, and that's going to be at pi over 2. So if you have to, take out your unit circle, that way you have all these values. But at pi over 2, those values there, x and y, are going to be 0 and 1. And we know that the y value right here is always pertaining to sine, whereas the x value is pertaining to cosine. So again, if you have your unit circle out in front of you, you should be able to see that pi over 2 is going to be the only place where sine will be 1. Okay? So that's our answer. We're going to say theta is equal to pi over 2. Okay? And again, since we're solving on this interval going from 0 to 2 pi, I don't have to include all solutions, meaning I don't have to put here plus 2 pi n. We talked about that in the other video. I'm done right here. Okay? So I'm going to go ahead and box this in. All right? And that's it. All right, let's go ahead and try another example. So here's our next example. And just like the other example, you can see that I'm not going to be able to isolate secant theta here, because I have a combination of secant. I have secant squared theta, and I also have secant theta. So this is very similar to a quadratic, meaning I'm going to say secant theta is equal to x. And then I'm going to make the substitution right now. So rewriting the problem, I'm going to say 2 plus 3x squared equal to 3x, and then plus 2x squared. So now you can clearly see I'm dealing with a quadratic. Again, how do we solve quadratics? Well, we set them equal to 0, we factor and solve. That's what we're going to do here. So we have to move over 3x, and we also have to move over 2x squared. We're going to end up subtracting both of them. When you do that, you get x squared minus 3x, and then plus 2. This is all equal to 0. So now you can factor it. So what two numbers when you multiply will give you 2, but add up to this negative 3 that you see here? Well, that's going to be negative 2 and negative 1. And since a, being right here, is 1, right, my coefficient there is 1, I can put it right in factored form, okay? So I'm going to say here, x minus 2 times x minus 1, all equal to 0. There it is factored. Now we can go ahead and resubstitute back in. X is going to be secant theta. So I'm going to say here, secant theta minus 2, and then secant theta minus 1, all equal to 0. Okay? So when you solve that, you get the following. You get secant theta is equal to 2, and then you get secant theta is equal to 1. Now again, I'm dealing with one of the reciprocal trig functions. I don't want to be dealing with that. So we know that the reciprocal of secant is going to be cosine. So I'm going to go ahead and put this in terms of cosine, meaning I just have to flip this value here and this value here. So when we flip that, we get cosine theta is equal to, well, again, it's 2 over 1. Now I get 1 over 2. And then doing this one here, that's 1 over 1. When I flip it, I get 1 over 1. So I get cosine theta is equal to 1. So now you use your unit circle and you say to yourself, when will cosine theta be a half? Well, we know that cosine is going to be positive in the first and then in the fourth quadrant, okay? So when will cosine be a half? Well, that's going to be at pi over 3. At pi over 3, right here, right, we know that cosine is going to be a half. And we also know in the fourth quadrant, cosine will be a half at 5 pi over 3. So right here, if you're using your unit circle, you know that that angular value is going to be 5 pi over 3. Okay? So those are two answers I can go ahead and include in my solutions. I'm going to say here theta is equal to pi over 3. And then I'm going to put a comma, and I'm going to say 5 pi over 3, right? Comma. So that takes care of a half. If I look at the 1 now, cosine theta equal to 1, when will cosine be 1? Well, that's going to be at 0, right? At this position right here. So I'm going to go ahead and include that in my solution as well. This is going to be 0. Because again, we know that our values here are going to be 1, 0. We know that the x value always pertains to cosine. This one matches up with what I have here. So again, 0 has to be part of my solution. All right, we're solving on this interval, so we're good. We don't have to include all solutions here, meaning I'm not going past 360 degrees, right? So this right here is going to be done. All right. Okay, let's try one more example. So here's our last example, and this one looks a bit complex because notice that we're not just working with one trig function, we're working with tangent and secant. They're both in the same problem. So whenever you have a scenario like this, my recommendation to you, move everything over to one side and see if you're going to be able to factor anything. So for example, this negative tangent theta, I'm going to move over to the left-hand side. Same thing with negative secant theta, I'm going to move this over to the left-hand side. And I'm going to see what happens. So I'm going to go ahead and rewrite the problem. I'm going to say negative square root of 2, and then tangent theta, and then secant theta, plus 2 tangent theta. And then when I move over negative secant theta, what happens? Well, remember, when I move it over, I'm adding it. And I already have a negative secant theta here as well. So what's going to end up happening, they're going to cancel each other out. So these are essentially gone. And so now this whole part here is going to be equal to 0. And so can you go ahead and factor anything? Is there a greatest common factor here? Well, look, this term right here and this term right here, they have a tangent in common. So I can go ahead and pull out tangent. So tangent theta, and then I'll have negative square root of 2, and then secant theta, and then plus 2. All equal to 0. So now I have two factors. I can solve both of them and then go from there. So if I solve this factor, that's pretty easy. I get tangent theta is equal to 0. So tangent theta is equal to 0. If I solve this factor, just doing it in our head, we're going to minus 2 and then divide by negative square root of 2. That gives me secant theta equal to 2 all over square root of 2. Again, it becomes positive because you end up dividing by two negatives here, okay? And so don't worry about rationalizing the denominator yet because I don't want to deal with secant theta anyways. I want to deal with cosine, which is going to be the reciprocal, right, of secant theta. So I'm going to put this in terms of cosine, meaning all I have to do is flip what I have here. So I'm going to say here cosine theta is equal to the square root of 2 all over 2. All right, and that's going to be way easier now when we're using our unit circle. So looking at our first one, we have tangent theta equal to 0. When is that going to happen on your unit circle? When is tangent going to be 0? Well, think about it. Tangent is sine over cosine. So we know that at this position right here, our x and y values are going to be 1, 0. And so remember, sine over cosine is the same thing as y over x, meaning I'll have 0 divided by 1 here. That will give me 0. So that's going to be part of my solution. So I'm going to start writing it out. I get theta is equal to 0. What else can I have? Well, this position here. We know that this is going to be negative 1, 0. Same thing, y over x, that's 0 divided by a negative 1. That's also 0. So that matches up with what we have here, okay? So I can include that angular value, which is going to be pi. So I'm going to put here pi, okay? And that takes care of tangent theta equal to 0. Moving on to the next one, I have cosine theta equal to the square root of 2 all over 2. Again, cosine is positive in the first and the fourth quadrant. And we know that that angular value in the first quadrant is going to be pi over 4 right here, right? So we get pi over 4. And the x and y values there are going to be root 2 over 2, comma, root 2 over 2, right? So we know that pi over 4 will work. And then for the fourth quadrant, what is going to be that angular value? Well, that's going to be 7 pi over 4, right? And again, you can use your unit circle to determine that if you have to. So you get 7 pi all over 4, okay? And that's it, because again, I'm solving on this interval, meaning I'm not going past 360 degrees, meaning I don't have to solve for all solutions that could possibly exist, okay? So this right here is going to be our final solution, all right? So that is it. That is how you can solve trig equations when they're a bit more challenging. Just remember, always try to isolate the trig function first. If you can't do that, you're probably going to be able to factor it, okay? Also, remember, do not divide out a trig function, because then you could possibly lose a solution and you don't want to do that, all right? So that's it. That's going to do it for this video. I hope that you learned something. I hope that you gained something from the video. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.